Let's talk about some properties of the dot product. One of these properties is the one we just talked about in the last video, and that's that if two vectors are perpendicular, then the dot product is 0. And this is a if and only if statement. So if two vectors are if the dot product is 0, then they're perpendicular, and vice versa. We have this nice property involving the dot product relating to the magnitude, and this one you can just prove by doing it. So say we take u1 dot u1 u2 dot u1 u2. That's going to be u1 squared plus u2 squared, which is the same as the square of the square root of the sum of squares. So that's a nice relationship. And then we have some algebraic properties. This is the commutative property. So you can switch the order and it's the same. This doesn't work for all products. It does work for the dot product though. And then this is an associative property with a scalar. So you can shuffle the scalar around and you'll get the same result. And then this is a distributive property. If you have a sum and you multiply the sum by a vector, then that you get the sum of the products. Okay, let's look at some examples. First example here. Let's decide whether vectors are perpendicular. Are perpendicular to 1, 2, 3. All right, so we have three vectors, or two vectors, excuse me, not three. Two vectors. Okay, so to see if it's perpendicular, we take the dot product. So -1, 1, -1 times 1, 2, 3. And we'll just multiply component-wise. So -1 plus 2 minus 3, and that is -2, which is not 0. So these vectors are not perpendicular. Let's do another one. So let's do -1, 1 times 1, 2, 3. And this one will get -1, -2 plus 3, which is 0. So these vectors are perpendicular because the dot product is 0. Another example. Let's fill in the blank to make each vector perpendicular to 1, 2, 3. So our first vector is -2, 2 blank. And our second vector is 6 blank 12. All right, so this one we'll just work it out. So we want the dot product of 1, 2, 3 and let's call the blank x, and -2, 2x, and 1, 2, 3 to be 0. So we want this to be 0. So we'll work out this side. This is -2 plus 4 plus 3x equals 0. So what is that? 3x equals -2, so x is -2/3. That's the number that you have to make this third coordinate to make the vectors perpendicular. All right, so part B, we want to find the y coordinate such that these vectors are perpendicular. So 6 times 1, 2 times y, 3 times 12. Sum of all those things equals 0. So we get 2y plus 42 equals 0. So -42 equals 2y. So y is -21.